Substitution effects in the context of information technology refer to how new technologies can replace older systems or practices, potentially leading to changes in consumption patterns and environmental impacts. This phenomenon occurs when a technological development makes it possible to perform the same tasks more efficiently. It captures both the benefits and challenges of such shifts. By introducing new solutions, substitution can lower costs and improve outcomes, but it may not always be in the best interests of planetary well-being if not carefully managed. A prime example of a substitution effect is the rise of online streaming services over physical media like DVDs or CDs. This shift has reduced the environmental burden associated with manufacturing, distributing, and disposing of physical media. However, the enormous data center energy demands required to stream content offset some of these gains and may in fact outweigh them. As a result, while the substitution appears beneficial on the surface, deeper scrutiny of the cloud's ecological impact is needed to determine whether this shift is actually sustainable over the long term. Substitution effects in IT relate closely to the concepts of resource efficiency, dematerialization, and societal behavioral change. Resource efficiency is achieved when less energy or material is needed to provide the same service, which substitution often aims to accomplish. Dematerialization occurs when fewer physical resources are used, as with digital downloads replacing physical media, though the energy used may still pose challenges. Finally, societal behavioral change is essential. People must be ready to adapt to and responsibly utilize new technologies for the desired benefits to be realized. These connections underscore how substitution effects may align with or diverge from achieving sustainable solutions. The substitution effects of electric vehicles represent a notable instance of technological impact on resource consumption and environmental health. When electric vehicles replace traditional internal combustion engine cars, they offer reduced emissions and decreased dependence on fossil fuels during operation. However, manufacturing electric cars demands substantial resources such as lithium, cobalt, and nickel for batteries, which raises questions about mining practices, supply chain impacts, and recycling demands. By understanding how this substitution affects ecosystems and societies, people can weigh these considerations when evaluating the broader sustainability of electric transportation technologies. Substitution effects are relevant to a range of technological areas, including renewable energy, data processing, and smart agriculture. In renewable energy, solar panels and wind turbines are replacing fossil fuel-powered plants, aiming for a cleaner power generation method, though land usage and material sourcing remain concerns. In data processing, edge computing has emerged, lessening reliance on distant centralized data centers. And in smart agriculture, precision farming tools help to improve farming yields while optimizing input usage.